Good morning, everyone. Welcome to our presentation Classification of Interview Topics on Emergency Remote Training. This research is conducted by Amay K and Jahnavi S to explore the effectiveness of transformer based models for classifying topics in Greek interview data. Introduction to topic classification is NLP. The first one is topic classification. It sorts data text into themes to aid decision making in various sectors. And second one is approaches. Conventional ML and deep learning, especially transformer models. Greek natural language processing challenges. It limited resources for Greek languages. This study compares machine learning and deep learning models. The main aim of this study is to evaluate transformer models on Greek ERT interview for dataset thematic classification. Related work on Greek NLP and topic classification. Greek natural language process. It studies highlight resources, scarcity, and need for domain specific tools. Applications include R, sentiment analysis, legal text, classification, and social media. The previous studies applied BERT, RNNS, and hybrid models to various Greek dataset, achieving high accuracy. However, the use of transformers in Greek interview topic classification remains largely unexplored. That's where our study comes in. Transformer models of Greek test classification. BERT variants. GreekBERT enhanced performance on complex Greek text, new architectures. GreekBERT and Greek T5 offer improvements in text classification and summarization. Greek specific models, GreekBERT and Greek Legal BERT, train on large Greek corpora for better accuracy. Research gap, limited application of transformers on Greek interview data. This study addressed it. Materials and methods, data collection and purpose. Interviews with parents, teachers, and administrators on ERT during COVID 19 in Greece. This mainly focuses on challenges, adaptations, and educational impacts to inform policy decisions. NLP automates the thematic analysis to handle large qualitative data set effectively.
Hi guys, in this paper we have three data sets. First is parent data set with 12 parents of our children and their functional diversity. With the data set, we have almost 14,820 and words data set. The school director data set, in which we have 15 directors with 17,171 words data set. And the last we have teachers data set with 20,014 words data set. The next slide we have data processing and model description. Before classification, pre-process the interview text into ensure high quality accuracy. Before classification, we pre-process the interview text to ensure high quality accuracy. First, we manually allocate sentences into four themes with a 93% intermediate arguments, ensuring reliability. Like classical NLP approach, we do not apply additional pre-processing for BERT models since they already handle text efficiently. However, attempts to use streaming and other modifications reduce performance reinforcement in BRT models, capacity to handle the raw text efficiently. For classification, and we apply four models and traditional ML baseline, MBERT, which is a multilingual transformer, XLMR, which is a cross-lingual model, and Greek BRT, which is optimally used for Greek language processing. Now, let us see how they perform. XGBoost, which we see the result model perform comprehension. Our, experiment, our experiments compare traditional ML model with transformer-based deep learning approach. Key findings shows that Greek BRT approached the highest macro F1 score of 0.76 outperforming other models. And BERT also delivers strong classification result. Classical ML models include XGBoot. Classical ML models includes XGBoot performs overall. We validate this result with cross-validation ensuring consistency and reliability. These findings highlights the advantage of transformers in handling Greek interviews. Data for topic classification shows visual comparison of result. The next slide we have is discussion. We are discussing on our models insights and their limits. Greek Greek BRT proves highly efficient due to its pre-training on Greek corpora. Greek corpora means it is a Greek document or Greek paper where making it well suitable for synthetic and symmetric analysis. However, some limitations more diverse model could further refine classification accuracy. Extendability techniques are needed to better interpret model decision. Strategic signals testing could confirm robust across the different datasets. To improve, we propose incorporative errors analysis, domain adaptation, and defining hyperparameters. To improve, we process the corporative error analysis, domain adoption, and refining hyperparameters tuning. These steps will enhance the real world applicability for education and policy decisions. And the last end of this presentation, we have conclusion and implementation. In this transformer model, outforms to traditional ML in Greek ERT interview topic classification. Greek corpus is pre-training to its key to its success, providing valuable announced language classification tasks. NPR automates the metric analysis, adding advanced based education policy making. And the most important, the study supports after AI research and interpreted language context. Now, after this, my colleague Jahnavi will give you some information about the code.
Study.
Start.
Hello everyone, I am Jahnavi along with my partner Amay. Today we will be walking through the code implementation of machine learning system that perform topic classification on interviews related to emergency remote teaching. This code is based on the research paper titled Classification of Interviews on Emergency Remote Teaching, and we have applied some enhancements to make the model more effective. Exactly what is this emergency remote teaching? Emergency remote teaching refers to the temporary shift from in the person instruction to remote delivery due to a crisis, specifically the COVID 19 pandemic. Unlike the planned online learning, ERTs is reactive. It was widely implemented across the globe during lockdowns. Teachers, students, and parents had to quickly adopt to a new tools, platforms, and learning environments. And the main purpose of this research focuses on analyzing stakeholders' interviews to uncover the main topics of concern and experience during ERT increase. Stakeholders included are teachers, school directors, parents. The main goal was to automatically classify what each speaker was talking about. For example, emotional issues, technical problems, or teaching quality. Why it is important? Traditional qualitative analysis, reading interview transcripts is a time consuming and subjective, and it automatically saves times, and it also enables analysis of large scale education data. It helps in policymakers, educators, and understand real problems and take action. The dataset came from semi-structured interviews conducted during COVID-19 lockdown in Greece. Interviews were segmented, broken into meaningful chunks, automated, labeled with one of the four topic classes. And the four topic classes were material and technical conditions, issues like internet access, devices, platforms, and tech support. Educational dimensions, teaching quality, classroom interaction, digital tools. Psychological or emotional dimensions, stress, motivation, emotional well-being of student and parents, learning difficulties and EIP, special education needs, challenges for students with ADHD or dialysis. Research objective. The main objective of this research is to train machine learning models to automatically classify interview segments into one of the four topics, and traditional models like logistic regression, KNN, and XGBoost, transformer models like MBERT, GreekBERT, and XLMR. And the key challenges of this we face during this research are non-standard grammar and informal language. This made traditional models less effective. This study tested if language-specific transformers like GreekBERT could handle this better.
So hi everyone. So this is the main code which we have written for the paper. So this first code we are using pandas library to and other libraries to get a data set which is already I've added already over here. So I just show you once run how it works. So once it run, it will download give us the file, and that we have to upload in the our collab file, collab folder. So this is the full structure of the code. Here we are giving the topic for the template to be added with the full content and options. How which is option we need to select and what they can select from the data. So this part of the code which I have wrote to get a proper data set with the balance class has already we have mentioned over there on top why the particular code has been used or written. So at last this code is to get the file, the CSV file for the case paper. Implemented in the case paper is XGBoost. So XGBoost, we have done the separate part. So this is proper. In this block, we have wrote all the installation, importing and installation, which files we are required to run the XGBoost model. So once run, it accepts or satisfies all the requirements. So here it loads the file, the CSV file, and it encodes the label. So most of the case paper is in Greek file or Greek format. So using XGBoot, the G stands for Greek boosting. So the Greek boosting helps us to take the data from Greek format to the English format, and then we can run it. So this is the preprocessor before running the final output. How the what preprocessor has to do is done in this part using we have used extend method from sklearn on top. We have almost already installed over here, imported it over here. sklearn for train test speed. So we are using train test. We have run the XGBoost, and here is the output for the proper data set. Currently, I am using the accurate data set, which gives me the total value 1. If I use an inaccurate or almost certain type of data set, that data set will be giving me almost some the data set will give me the answer in 0 point some 6979. Any data set cannot, or the data set should not be never it will be in 70.70 raised to 30, 80 raised to 20. In that ratio it never it would be. So this is an accurate data set, that's why it's showing 1.0 and all. So the second model which we have used is embedded. So embedded method means the second method we have used is embedded. So in embedded method, I've compressed all the parts into one file only, so we can run it together. But some embedded parts and other parts takes too long to get run. So I've already run and kept the output, so we can explain it faster. So here are all the input files and setup files we require. Now, in this block, we are customizing the data set using self.text equals to text.toList. So in that text list, we are even setting it to self text or something and others. We have also used the simple concept called tokenization and all. So in step 3, we are routing the tokenization to the model. So the model which we have done, embedded model, to run that model, we are using tokenization and the code which we have used is tokenization equals to auto tokenization dot from pre-trained model name. And to set the pre-presentation, we have used train dataset. And to train the dataset after the train, to train the dataset after the pre-presentation, we are using training command, which optimize and gives a proper trained dataset. At last, the evaluation means how the dataset should be run and what output should be given and what in what method it should give the output. So part is written for that. At last, here is the output, the same output, the accurate output. This output, every output is coming 1.0 because this is an accurate data set. So if anyone is interested, they can try this code with not accurate. They can take a simple data set or scrumble data set and can try. I'm not running this code just because it is here. We can say that the first part is took 10 minutes to load, then other part take 9, and so on. So if I run this part, it will take almost 20 to 30 minutes to get run properly. So say this is the logical regression part. I have wrote all the common imports in every model again and again just because if we need to run this part only logical regression, then we can copy the full regression code and we can run it separately. If we use if we have the same import parts and other and we are not I'm not importing it again, then when we are running this separate, we have to find every import part which is satisfied or not. That's why I wrote import part every time separate with their loading dataset code again and again. So if we need to run the same part again, then we doesn't need to search. Only directly take the whole script and run. That's why I've taken the whole code. Now this is to load the dataset. Say these all almost are the same which we are using in other dataset embedded, XGBoost dataset and all. These codes are the same which we have done and loaded in before dataset like MGBoost and XGBoost, embedded and XGBoost. So here it is giving the output. The accuracy is 1 because the data is accurate. So classification import. This is the classification is done using logical regression. The report of that. Now, this code was mostly done. We are referring to the case paper. In that case paper, how the data set, data tables, and the diagram graphs was there. This code is to represent that. So we have taken our CSV file and made to have the same data set and the graph tables and graph. So here is a table which has material technical conditions is 20. Psychological emotion dimension is 120. Education dimension is 120. So this at present this data is accurate. The data set which I have is accurate. So the values will be same throughout. Here we have wrote the code for the second table and second figure which is given in the main case paper. So this was the output of the data set, the table which is given on the first case paper with the represent with it is represented as a table. And this is the third model which we have preferred to use in the main case paper, which is XLMR Greek. So in that we have again I have done the basics importing and installation again with the file. Here we have mostly used different types of custom data sets, and wrote in this I've used the same import commands and or other, but in this one we are using one more extension or one more type, which is device. We are using device command to get other data variables which is imported in it. The models, the data loaders, how the data is here the train data set is used to get load the data, and this last second part, the seventh part is we are training the data model and how we need the output. So now in the fourth model, the BERT. Greek BRT is mostly used because this case paper which we was the model for Greek BRT model which was referring model for. Model for is mostly we have used we have selected Greek BRT because the main file was of Greek. It's from Austria or some other place, and the main output of the file the data was origin in Greek format, Greek text or Greek language. So to understand better in English, that's why, or to understand in other languages, that's why we have used Greek BRT method. So here is the code. In this almost 70 to 80% codes are the same. Only some one or two models are we have used differently, like encoder class labor, we are encode labeling the class which is getting encode. Same tokenization method for this one, and training arguments, training to it, train method to it, it's get run easily. So here is the output for that, and the same accurate table. So there is the code for figure 3 and table 3. So there this mostly we have wrote the code to referring to the main diagram and table given in the main file. For the table there was almost 3 or 4 tables. So here is the code for table 3. Here is the output for the table 3 of the output of the table, and same in the graph format. So almost there are almost almost 5 to 6 tables. So here are the outputs of for them, code and output of them. So I'm just keeping that because the because the main thing we have tried if it is giving the accurate answer or not, because the main case paper was having the main case paper was using less of data set. The data set was not accurate, so we have tried with the accurate data if it is giving or not, and then we have also tried before we have tried with the inaccurate data, and this is with accurate data. So the last model or last part which we have used is pair plot to get a proper diagram view of the table, how it is the data is flowed and all. So in this we can easily refer that the table or the graphs is almost labeled properly, right? And is for technical, the yellow line is for emotion and all. So the data was accurate, so therefore it was showing in this one sentence count, it was clearly point 1, not point 1.2, 1.02 or 0.98. There are different method which we can refer to it. So word count in every, there is a word count and average word length. So average, what was the length of a word, and what is the how many words it was having, average words. Sentence counting, so every sentence we have taken, yeah, as per the data it was accurate, so it's almost coming point 0.1 only words, and how many emotional and other words are there. So here is the basic code for them. Here is the basic code for pair plot, which has import command, Then download same command for loading the data set, generating numeric values, and others. Referring to the preparing of the graph, different graph for this. Step 5 is mostly referring to graph of word count, sentence count, average word length, and others. This was an optional part which we can add, which we have added that we can to for. This was an optional part, but which we have added to get the get or able the output. Then is showing what data. That's why we have used the optional code. Step 6 is to prepare the whole report and show the output. Thank you for listening our presentation and the seeing to the codes.